Now it's time for dark blue. Dark blue says, for what values of x does h have a relative maximum? A relative. Guys, the word relative is the same as local. Okay? Local max and relative max, same thing. All right. So locally, where do we have a max and where do we have a min? There's a couple different ways to figure this out. And so this is going to be an extra long explanation because I want you guys to see both ways. Okay? So what we have to do is we have to find critical values because that's where you could possibly have a max or min, a local max or local min, or I can say relative max or relative min. So the first thing I'm going to do is find h prime. So I find that and I get 5x to the fourth plus 4x to the third. Then I'm going to take this dude and I'm going to set this dude equal to 0. This is a polynomial, and so it's not going to have a d and e anywhere. So I don't have to worry about where it does not exist. But where does this equal 0? And so I'm going to factor out an x to the third, and then I get 5x plus 4. Now what I'm going to do is I'm going to use the zero product property, which says one of these numbers, I have two numbers multiplying to each other, one of these numbers multiplies to give me 0. And so I take the x to the third and set it equal to 0. I get 0. I set 5x plus 4 equal to 0. I get negative 4 over 5. Okay, so this is where we could possibly have a relative max or relative min. But we want to know where we have a relative max. Okay, so here's my sine line graph that I gave to you guys before, and I'm going to make this for h prime. So this is the h prime, this is the x-axis. We have two numbers here. We have 0 and we have negative 4 over 5. Okay, now I want you guys to stop and think for a sec. Whenever you have a max... Wait, what happened? Oh, thank you. We got to switch these. Okay.
Oh, yeah. No.
My bad. Okay, whenever we have a max, what is the function doing right before the max? It is increasing. And then after the max, what's the function doing? Decreasing. So if you know that you're increasing then decreasing, then you know you have a max. So you want to have a positive then a negative. And then this would be a max. Or you would have it over here, a positive and negative. Then this would be a max. Okay? So if you get a positive negative, then you
so if you were
have a max.
Minimum, then you do a negative positive.
Right. A minimum would be a negative positive. So guys, this is one way you can find it. And what we're doing is we're using the sine line graph to do that. Okay? Now, this is what I like to use, but keep this in mind. FRQs from College Board, they don't count that as work. You have to say what's happening with the sine line graph. They don't assume that you know what's going on. So we're going to have to test some numbers. I'm going to test negative 1, negative 1/2, because that is definitely between negative 4 and, or negative 4/5 and 0. And I'm going to test 1. Those are my testing values. And you can test whatever value you want, okay, as long as it's in that interval. So I tried negative 1. I plug in negative 1 to the h prime, right? Because it's the h prime sine line graph. I plug it in here, I get a positive. I plug it in here, I get a negative. So I have positive 5 plus negative 4. That's going to be positive. Hey, that didn't require much work. Okay, negative 1/2. So I plug it in here, I get a positive, right? Times that. And this is going to be a positive as well. No, that's also going to be negative. But we're multiplying this. It's a small number. I'm kind of nervous.
16 and 1/2.
We better write this one out. Okay, so we have 5 times, what is 2 times 2 times 2 times 2?
16.
That's positive 16. Okay, and then I have 4, and this is going to be negative 1/8. Right? Right? Are we good? You guys with me still? So this is going to be 5 over 16, and this is going to be negative 4 over 8. Yeah, this number is definitely bigger, but if you weren't sure, you can make it have common denominators. And so we have more negatives than we have positives, and so this interval is going to be negative. Everybody good so far?
Yes.
Okay. Now, actually, because we're decreasing here, is there a chance that 0 can be a maximum?
No.
That's what we want, a maximum? Yeah, it could be a minimum if this is positive right here. But you know what? I don't really care because I only need a relative max. And so my relative max is at negative 4/5. This is where...
If it asks for both, then you get into that situation.
Where it equals, okay? That's
So
where...
you're combining the negative and positive and fact.
This is where we have a relative or local max, okay? Does everybody understand why we know this is a local max? Because the function h, that's this guy, is increasing then decreasing at negative 4/5. I'm going to show you another way. And the reason I'm going to show it to you now, usually textbooks don't show it to you until later, but I'm going to show it to you now because it's coming. You might as well know both ways now. This way I say is using the sine line graph. There's another way. And the other way is using the second derivative. Okay? So we have to talk about something new. We have to talk about concavity. Okay? This is concave down. And this one right here is concave up. This will be in your future KISS notes. When you're concave down, the second derivative is less than 0. When you're concave up, the second derivative is greater than 0. That means the second derivative is negative and the second derivative is positive. You guys still with me?
Yes.
Okay. This would be a local max. What is the second derivative? Is it positive or negative? Negative. This one is a local min. Is f double prime, the second derivative, is it positive or negative?
Positive.
It's positive. So if you know the concavity, you know if you're positive or negative. You guys got that? So what I could do is I could find the second derivative, which is going to be 20x squared, or to the third, plus 12x squared. And then I could take the 4 over 5, the negative 4 over 5, and I can see if we equal a negative number. If we equal a negative number, then we know we have a local maximum or a relative maximum. You guys got that? So, yes. So I have 20 times a big number. Negative 4 times 4 is 16 times 4 is 64. 5 times 5 is 25 times 5 is 125. And then we have, this one's not fun. I don't know if I like this way. Okay, negative 4 raised to the second power. So it's going to be negative positive 16 and then 25. Okay, which number is bigger, the negative or the positive? I don't like this. I'm going to make this into a 5. A 4. And this one's going to be a 25. Right? Just divide by 5. And so I have 4 times 64, which is really big. So I'm just going to go 4 times 64. And then this one I have 12 times 16. Which one's going to be bigger, 12 times 16 or 4 times 64?
I don't think you really know.
We got to figure that out. I don't want to. I don't want to do it.
12 is a lot for a small number.
Okay. All right. So let me pause right here and do it really quick. All right, so I multiply them out. 256 is 4 times 64, and 192 is 12 times 16. So that means this result is going to be negative. F, or H double prime, at negative 4 over 5 is less than 0, which means the concavity is down, which means this is a relative max.